All right. So let's talk about control things and some pen testing. So as Rob mentioned, we have some challenges. Anytime that we want to go ahead and do some type of security assessment or penetration testing in some type of control environment, there's always going to be some challenges that we have to face, right? So here's what I consider the three biggest challenges. Number one, the easy one, is the safety and the reliability of the system. Well, how do we address that? If we want to do some type of a security assessment or penetration test, right, try to identify vulnerabilities or flaws inside of either our systems or inside of our defenses, our architectures, our networks, right, we have a couple options. The easiest option is we simply don't, right? And that's quite the option that all of us take, and it's a guaranteed level of risk, at least a risk of not crashing things in some type of a security assessment scenario. So that's definitely the easiest thing. One thing that we can do, if we choose not to do any type of penetration testing or security assessment of our control systems, is we can go ahead and at least do penetration testing up to our control networks, right? So go ahead and do penetration testing and assessments from our enterprise, trying to come up against the perimeter, or all the ways that we have sanctioned to be able to get inside the control networks. We can also go ahead and do some level of penetration testing or assessment on any type of device or solution before we put it into production, right? So that's something that if we can put it in some type of a lab scenario, and if it's reasonably, the price or the risks involved with trying to do a penetration test of that solution makes sense, then we can go ahead and do that, right? Or in some type of facility environment, right? Some type of manufacturing, any type of a larger location, we can do some level of a network penetration test as well before we complete any of our SAT testing, right? Before we go into production, before we get the plant commissioned and start running. Now, even in these scenarios, we want to be careful, right? The cost of some of these solutions are very, very high. The last thing you want to do, even though it's not in production, right? There's no processes running on it, you don't want to be destroying multi-million-dollar pieces of equipment. So there's always going to be some type of a logical decision in here, right? The more difficult approach about penetration testing is if you choose to want to figure out how to do penetration testing inside of your environment, that's a lot more difficult to be able to do, right? Because then we do have to face some of those risks. But there's also some reasons why we want to do that, and that's because the attackers attack the production systems. Right? We want to be able to at least understand a little bit of what happen if an attacker gets inside of the environment, but be able to do it in such a way where we have all hands on deck. We have engineers present. We have control over the scenario. We have control over what's actually being done. Right? And very few ICS organizations actually do this inside of production. I do have one customer that's a transmission operator that does have a team of pen testers that actively pen test their transmission substations. Right? Trying to identify vulnerabilities and flaws in them. But it's taken them many years to be able to build that experience. It's taking them many years to be able to go site by site, substation by substation, and try to identify with operators and engineers on hand what can and can't be done on each one of these systems, right? So it can be done, it's just a very lengthy process. And if you want to do that, right, there's challenges to face with, number one, what type of personnel are we going to try to hire that has that skill set, right? Where can we find them? Where can we train them if we want to try to build those internally? And once we even have the people or the staff or some type of a third-party consultancy, which I guess is always an option as well, right? The next hard thing to do is, what about the tools? How do we, if we choose or want to do some type of a security testing, either in a test environment or if you've done all the due diligence and decide to do a lighter weight version of pen testing in a production environment, how do we find the tools to do that? And that's always a huge challenge because there's not a lot of options when it comes down to the tools that are there. I've been doing penetration testing in the control system environment for the last 10 years, and we have gotten very creative with our penetration testing tools. So what are some of the solutions that we actually have? Well, wrapping penetration test tool or wrapping scripts around existing engineering tools. Honestly, we do that way too much, right? If you can get your hands on engineering tools, right, that's not always a given. You may or may not be able to do that. But if you can get your hands on these tools, you can wrap scripts around them. But there are some challenges to the engineering tools. Number one, most of them are written for Windows only and only available on Windows, which isn't bad. I don't mind doing pen testing from Windows, but there are some severe limitations on what the Windows operating system can actually provide for us in these scenarios. The other problem is most of them are graphical-based tools, which means if I want to be able to script around them or use some type of an engineering tool that's graphical-based to be able to perform some automated functions to do testing, I have to get creative in how I can control that and script that. And if you've ever tried using some type of a macro-based tool inside of a graphical environment to have it automatically find the right box, automatically populate it with the information, automatically send whatever request by clicking on the appropriate button, detect when the screen changes when you get some type of response back, which may or may not change, which gets even more creative, trying to identify when the tools actually send something, and then trying to figure out a way to be able to extract information and data from that graphical tool back into some type of analytics database, spreadsheet, even a text file, right, to be able to do your assessment. So there are some very severe limitations trying to use engineering tools. We can do it. We've made it work. We still make it work, and I don't see this changing. We're going to continue to do this far into the future because we simply are never going to be able to make enough tools to accommodate the vast myriad of vendors and protocols and different types of tools that exist out there. So other options. Besides trying to do the engineering tool approach, we can try doing the network pen testing tools, the tools from the IT world, right? That works pretty well because most of our control systems are vulnerable because of the IT technologies we've added to them. So therefore, we should be able to use the IT tools, and we can. And we still do, and I would say that if you look at almost any of the firms or companies that are out there that are doing penetration testing, either professionally as consulting services or different types of employee teams doing penetration testing inside of their environments, right? I would say that that's probably a big piece of what they're actually doing, is using a lot of these IT tools to do a lot of the testing. But there's some limitations there as well. Most of the IT pen testing tools primarily focus on TCP/IP, right? They don't understand the ICS protocols, and they don't address anything outside of TCP/IP, right? You would think, oh, well, a nice TCP/IP tool would work well with some of my Ethernet-only protocols, like Goose messaging. Yeah, sometimes it does, sometimes it doesn't. Depends on what you're trying to do with Goose. So that becomes a bit of a challenge for you, all right? And then what about everything that's not Ethernet-based? We have lots of serial-based connections, including field bus protocols and a myriad of different types of field bus protocols. We have proprietary maintenance interfaces and other types of interfaces that are proprietary hardware, proprietary wireless from our ICS vendors that we may want to be able to test, right? So that becomes a bit of a challenge to try to do. And we have any other types of maintenance interface. It's just kind of like an endless list of what could be inside of some of these environments. So we can do it, but it ends up being, if that's all you're dependent upon and that's all you're using are the IT tools, you end up having some major gaping holes in your assessment methodology and in your final test once you're actually finished. So the third option you can have, which almost all of us also rely on, is randomly searching through GitHub, hoping you can actually find a keyword that gives you some piece of code of this written in a program that you're comfortable with or like or don't hate, right? Because that does play into a factor, to be entirely honest. There's only so much JavaScript one can deal with in their life. JavaScript tools written for the ICS environment running on Node.js. Anyway, so a lot of different types of GitHub tools. Problem is, we don't know the authors, right? They're unknown entities that are actually out there, which means in order to use these in some type of environment, we need to do some level of due diligence to try to validate that there's no maliciousness in it, there's no phoning home, there's no data leakage in the tools, and any good pen tester should know his tools, which means before I use any of these tools in production, I need to make sure I have a very firm understanding of exactly what the tool does. If it sends traffic, which they all do, right, either through a serial bus, USB bus, RF, raw RF packet, or Ethernet interface or field bus interface, right? If they send that traffic, you need to know exactly what that traffic is, right? Exactly what that traffic may do to the system or to that environment that you're actually working in. So that becomes a bit of a challenge for us for anything that we're trying to do. And the other problem is when you use these GitHub tools, right, which often is probably some of the best sources we have to be able to do some of the more specific ICS protocols, a lot of those libraries and tools are very, very limited in their feature set, very limited in what types of protocol requests they can actually send, right? So these are all challenges that we deal with if you ever try doing penetration testing inside of a control system environment. Hey, leave me alone. So moving on, but on features needed. So what do we actually need in some of these tools, right? These are things that over the years I always dreamed that I have, always hope I can get my hands on, or try to implement as I'm going through and creating these tools, is we need to go ahead and try to have, you know, some very specific features. If we're doing penetration tests, we can use engineering tools to be able to interface and interact with the systems themselves. But the engineering tools, even if you ignore the scripting part and I just use the engineering tools manually, they often are lacking in some of the features that are considered critical to be able to complete some type of a penetration test. So after all the years, kind of what I've done is this is kind of my dream list of anytime I have a pen test tool, regardless of the protocol, regardless of the control median, regardless of the technology that it's interacting with, these are always the features that I'm looking for in any tool that I'm using for a penetration test, okay? So breaking them into a couple categories. Number one, need to have some way to be able to have a flexible interface because I don't always have the position in the network infrastructure or in the assessment or in the system to be able to run a specific operating system with a specific graphical interface. Sometimes I need a command prompt. Sometimes I need to be able to use something in Windows. Sometimes I need to use it in Linux. So I need to have some flexibility there. Okay? Number two, the ability to be able to report and record exactly what I'm doing. There's a liability to doing penetration tests. I want to be able to prove exactly what I did. I want to have a record of every single bit that I sent on that wire, right? And because we usually do penetration tests with teams, or at least a pair of two people, right? The ability to be able to export my current data set that I'm actually working with and have somebody else import that in seamlessly, or export it to be able to save for a longer period of time and be able to re-import it in down the road, right? So the ability to import and export projects, basically. So that becomes a very important feature that we need in our tools. In fact, the funny thing is in the IT world, it seems like only 10 to 15% of the IT world actually includes that type of a feature in them. So the next one, looking at protocol-specific tools. So if I have a tool that's talking a very, very specific protocol, right, there's a couple different types of features that I'm always looking for in these tools. I'm looking for some type of a client interface, something that I can actually send requests and have control over exactly what's being sent in the request, right? So a lot of the engineering tools actually fit this need where I can send unique raw manual requests, because that's how a lot of the engineering tools are created for the engineers to have a little control for testing, right? But when you have these client tools, I also need to be able to send not just one raw request, but a variance of raw requests, some basic fuzzing capability, you know, to be able to, inside of there. So some automation in what's being sent becomes an important part. We need to have some type of a server mode, because when we're doing penetration tests, you're not always testing the listening port, right? We're often going through and trying to test the opposite end of the conversation. So think about the ICS world, right? Inside of our control protocols, when you get down to Purdue level 0 and 1, it's always the field devices that have the listening port. They're technically the servers in the network communication, right? And the client in those scenarios are what we usually call master servers, right? Which always gets really confusing. But we end up having the layer 2 and layer 3 devices, which tend to be more the server-like platforms running on Windows or Linux server operating systems, right? Have the client-side tools in the equation. And if you look at the difference between risk, what's more important, right? That one single field device or the one single server that's acting as a client that's actually talking to hundreds to thousands of those field devices, right? If I can choose to compromise only one, I think the choice is really easy. But the problem is a lot of our fuzzing tools and a lot of the testing tools focus on testing the requests, not the responses coming back, right? And you go back and look, what was it, back in 2002, 2003, when Adam Crane first created Aegis and was going through and detecting all the vulnerabilities in DNP3, right? He was having a heyday on the responses to the servers because nobody was actually testing that. Most of the companies that were doing any type of protocol testing we're only testing on the requests that we're going out to the field devices, not the responses coming back into the client software running on the layer 2 and layer 3 servers. Okay, so that becomes a bit of a challenge. So we need to have a server interface which can do fuzzing, which can do testing, and can also allow us to have something to configure or calibrate our client tools on, right? Because before we ever go onto a site and do testing, we need to learn how to use the tool, and we want to make sure the tool is still functional before we go through and use it. Or if I'm going to try something that I haven't done for a while, right, it's probably better to test it in some type of a lab scenario first. And if your tool automatically supports some type of a server mode, I just run 2 instances of the tools. Bring one up into server mode, bring the other up into client mode, go ahead and test against my virtual test environment that everything's actually okay, right? That I know what that process actually looks like. So that becomes a need. A proxy mode, right? This gets a little bit more exotic. We have great proxies inside of the web world. If anybody's done web pen testing, you know exactly how useful something like Burp Suite or Z-Attack proxy is. Can you imagine a Burp Suite or a Z-Attack proxy for any random ICS protocol you wish? Having that tool set, okay? That would be an awesome tool set to be able to have. Okay, then we get into the ability to export, create, export, and import in different device files. Because when you're working on a specific protocol, right, you may be working on specific devices, and once I've tested one device, if I can go ahead and build a known knowledge base of what requests are common on that device or which tags that device normally has in that one single scenario, I can then go ahead and reuse that same profile anytime I test another similar device. Gives me a starting point, right? So that becomes something useful to have that we don't have in hardly any tools out there. Then we get into the generic protocol tools. We need to have generic protocol tools, something that will work across specific communication interfaces. So things for TCP/IP, we're pretty well set. The IT world has tons of tools that are generic testing tools for TCP/IP, right? But it's the other ones that get a little more difficult. Raw generic testing tools for things like Ethernet communications, okay? Raw Ethernet communications outside of TCP/IP. We have some in the IT world. You get into serial, field bus protocols. Virtually none. The closest that we usually have for serial testing in the IT world are tools like PuTTY, right? Or some type of mini-com, something that gives me some type of a serial interface that's ASCII only. Well, the problem is most of our serial protocols are not ASCII protocols. They're binary protocols, which means we need to have a binary tool to do that. Right? Then we get into USB, and RF becomes all other interfaces that we may need to have capabilities for. For these generic tools, having the way to be able to capture communications between 2 different devices, and inside the interface, when I have the capture, be able to define the protocols on the fly as I'm reverse engineering that protocol, right? Because that's what we do as penetration testers. We find a new protocol we've never worked with before, which in the ICS world happens all the time. It's part of the fun of the ICS world, right? Finding that new protocol, controlling what I actually send from the user interface, capture it, figure out exactly what the command string was sent, go ahead and try a different command, diff the 2 commands, and slowly start figuring out what the communication streams look like. Well, we can do that, but it would be nice to be able to have that knowledge back into the tool, so then we can go ahead and start leveraging that inside of the tool for the client side and the server side communications. Right? And then the ability to do macros and fuzzing, because when we work with generic tools, we end up creating these very, very custom commands, either big, long streams, and instead of typing that whole thing every single time, it would be nice to say, hey, to send all this, just go ahead and name it this macro, right? Type the name of the macro, and it sends this big old long stream for you. Okay, so that becomes some important things. So these are all what I consider features that we need to have in order to do a full, complete penetration test, right? Something I envision for the future of the ICS world. I'm trying to tackle this problem. I have some tools that are currently out, and they are available to download right now, right? Now, they are not fully complete to that entire master dream list. I will go ahead and show you exactly where they're at in just a second. But these are some of the tools that I currently have out that are publicly available. You can go and download it at controlthings.io. So on that, I have a generic serial tool to be able to do raw serial communication and be able to build macros, right, to be able to send those custom streams back and forth to devices. I have a tool for Modbus protocol because, of course, it's the easiest one, and there's tons of libraries available for it, right? But one that kind of is the child test case that I'm trying to build for custom protocols. That's publicly available. Protocols for raw serial interfaces on circuit boards, right? Because when you're doing any type of circuit board testing in the embedded world, Serial communications on those circuit boards are usually SPI or I2C, right? So I have some tools to deal with those protocols, right, that are more specific protocols on top of a serial bus. And then I have control things, which is just kind of a fun one I threw together for the PLC that we use inside of ICS 410. And then the control things UI, which isn't technically a tool, but rather the library that all the tools are based on, which I'll show you here in just a bit. Okay? So to give you just kind of a little bit of an idea of what these tools look like, they are all sharing that same type of an interface, right? Trying to accomplish that feature set that I previously mentioned inside of the tool. So this is looking at that ctmodbus, which is available online, right? So this is a command line interface. So it is flexible, but it is command line graphics, right? So we actually have some type of a graphic interface. In the future, I do foresee doing some type of a web interface on top of this or a graphical tool to be able to have better graphing capabilities to analytics on the devices. But because this is always something I always need as a command line tool, that's where I started. So here's the basic functionality, right? Be able to read. Because it is a command line tool, which generally is not necessarily user-friendly to a lot of people trying to use these tools. The nice thing is it does do automatic tab completion for you, right? So as you start typing, you'll notice all the different fields that are present. Every single time you come into a new field, it'll kindly tell you which options are there and give you a nice little definition for what types of options that are there. When it comes down to flexible formats, right? I mentioned I need to have flexible formats to the input that's not very limited like a lot of the engineering tools. Well, if you look at any of these examples, right, for the read coils or read discrete inputs, look on the far right-hand side for the format that's present. Comma-separated ranges is what I like calling that. We end up going through and specify very specifically, I want this register, this register, this register, this range of registers, this register, right? Because sometimes when you're doing a pen test, you usually narrow in exactly what I'm interested in. I want to kind of forget everything else, right? And be able to see just that information. And that's something that I can't tell you how many times inside of using engineering tools I can request one specific address, or I can or request a range of addresses, but that's it, right? So having some flexibility in the input, I just kind of give you a little bit of an example of that. Having some flexibility in the output. Another thing that I get really, really tired of inside the ICS world is when we end up working with a lot of the different tags or endpoints that are there, you do a request and you end up having like 50 pages, right? As you're trying to enumerate these devices and I'm trying to scroll through it all, trying to figure out what's there, and they're like all zeros, like 95% of them are zeros. So having some type of a summary. So the back end is the raw bits that were actually sent, so I do have a record of all of it. And then that little summary screen on the success basically will summarize. So notice that I have unique settings for 1, 2, and 3, but 4 through 10 are all actually set to 0, right? So a very summarized output so I can very quickly try to go through and try to analyzing it. And that's just a very simple example of what I like to see when I have output coming back through the tools. Of course, when you're doing fuzzing, it would be a very different way to be able to summarize or analyze that information. So to give you a little bit better idea of specifically the ctModbus tool, I have a beta version that's currently out online that you can go download. It has most of these features that are on this first slide. What I see here, or what you see here in these slides on the left-hand side, that is the command that you would actually go through and type, right, with some different examples to try to give you some understanding of different flexibility on the inputs for doing that. A nice little description on the far right-hand side of exactly what that command is doing, right? Notice that we can do individual tags, reading and writing of them, polling them, tags, going through and creating tag databases or importing and exporting tag databases when it comes down to Modbus devices through the device profiles. Some of the additional commands that we have. So these are the ones that I have most of these to some partially implemented inside of development. This is one that I'm trying to finish the rest of these commands here in the next few weeks and trying to get this pushed back out publicly. So we have a full complete data set with almost every single feature that I mentioned, right? At least for the Modbus tool, which has kind of become my main use case for trying to do a full feature rich tool there, okay? So on this one, some of the extra ones that I'm still working on is being able to do some of the proxying capabilities inside of the tool itself, right? Being able to do tunneling through it, which basically is kind of like a covert channel via Modbus, either for shells or for pushing of files. That way we can actually test our security tools to try to see if they can detect anomalies that are true protocols, right, but that are very different than our normal traffic patterns for the ICS world. Because that's something we're always questioning in the ICS world is, are they really looking for anomalies outside of, oh, this is the protocol between two endpoints, right? We want to have a little bit more better knowledge, and that'll allow us to test some of those tools. And then be able to actually push this out for a historian so you actually have a record of that information. So here's the roadmap that I have for the tool sets, showing you kind of which tools that are out there, which tools are in development. So checkboxes mean that piece is already done. Of course, the projects is easy because that's part of the user interface and library that's already done. When you get into anything that you see in green in dev, that is something that either completely done inside of my development version that is not public on GitHub yet, or components that are partially implemented inside of my current local version, which I'm hoping to get out here in the next few weeks. Planned is going to be anything that I haven't started on yet, but something that I definitely have planned to be able to do for those tools. If you look at some of the protocol-specific tools that are there, all the ones down the bottom that I haven't started on for those ICS protocols, those are all ones that I do at least have usable libraries for that I have been able to find. I've done some experimentation to verify that I will be able to use those libraries. And so that's something that hopefully shouldn't be too bad. One of the biggest things that's been holding me back on this project is I started writing each one of these tools individually, and then I started realizing how much of each one of these tools was really duplicate code between the tools. So I kind of took the last 6 months and have been putting all my effort into the generic library and trying to have a generic library together. And so honestly, out of all the tools that I've written so far, my library is probably the thing I'm the most excited about. Because the library that I put together, which is ctui, gives me a nice little interface to be able to work on that. Oh, and this is just a screenshot of the Control Things platform. It's a virtual machine that I've created. If you ever played with or heard about the Samurai STFU, the Security Testing Framework for Utilities, right? Make sure you don't get the acronym messed up there. But that's a project I've been running for, the last 6 or 7 years. I think 7 years. I think I launched it in 2012. I have completely rebuilt that over the last year and re-released it, changing its name to the Control Things platform. And so this is a platform. All these tools will be located on there, as well as a whole bunch of other tools. Some of the new things in the Control Things platform compared to the old Samurai STFU is, besides having a lot more tools and features built into it, I do have the Kali repositories also built in as well. It's not based on Kali, but it's based on Debian testing, which is what Kali is based on. So if you ever get into a pen test and you think, oh wait, Kali has this tool, I really need this tool, just apt-get install the name of the tool and it's there, right? So you will have that. So, but back to the Control Things UI. Control Things user interface. This is that library that I've put together, created, to be able to facilitate building all these different types of tools. This is something that's also open source. So all these projects, open source, all these projects being pushed up to GitHub as they're being done. So they're all publicly available. All of you guys can feel free to take them, run with them, reuse them. But one thing I wanted to show you about this Control Things UI is kind of show you why I'm so excited about it. And it's primarily because of the flexibility of this tool. How fast it is to be able to go through and create a simple graphical interface on a command prompt for this. So this kind of is just a little default tool just to show you the bare minimum number of lines of code of how to write this. It is all written in Python. All the tools at this point are all written in Python. I do down the road would like to rebuild or at least start migrating to Golang, which would facilitate the deployment of a lot of these tools where I don't have to worry about existing libraries. Just have a compiled binary file. But for now, everything's written in Python. So all you need to do is just go ahead and import in the ctui library, right? Once you import this in, you just go ahead and you create an application, give it a name. So I named this application My App, right? And My App is going to be a ctui. And then you just go ahead and run My App, okay? And just doing that, 3 lines of code, this is what it gives you. So let's go here, Python, default Py. Okay, so here's that simple little interface. When you go ahead and do it, just in those 3 lines, these are all the commands that are present for you. So all the project file information is actually already there. help capability is all there, history capability is all there, keeping track of the history of everything you do inside of that interface itself. It is dynamic, so as you resize your windows, everything is asynchronous, so everything will automatically resize as you're going through and doing it. And with the ctui, you don't really have to worry about or think about how to deal with a graphical environment or windows or locations. Everything's just kind of set up for you. Nice, straightforward, and simple. So once you get inside of here, as I mentioned, you can start typing. So project, right, hit space, automatically shows you what the next options that are. So for the projects, I can delete projects, I can export them, import them, list all the projects that are there, I can load them, reset them, or save as, right? So if you go ahead and do something like, I want to do a save as, whoops, save as Justin. Okay, so, oh, it already exists, do you want to override it? Yes, automatic. So once again, this is stuff that's automatic, happening for you. It should be cross-platform. I haven't checked the latest version back on Windows. But it is tested on Mac and Linux. And like I said, I have tested earlier versions on Windows. I can't think of anything I did that would have broken the Windows implementation. So it should be entirely workable in Windows as well. Okay. Then I can go through into a project list, right? Show me a list of all the different projects that are there. Project export, project import. You kind of get the idea on that. So that's a nice flexible interface, something very easy that's already there, all the software or the capabilities there for free. So another one is if you wanted to have a little capabilities and start adding your own commands. Here's a simple example I have in the repository for an example of how to do a file system, right? So as long as you know the 2 commands inside of Linux to be able to send something from Python down to the command prompt, or sorry, to the operating system to get a list of files or directories, which is cross-platform, it's pretty easy to write any tools you want. So once again, here's just the importing the information in. Here is setting my app. So before I already had the my app in the previous example, the only difference here is now I'm kind of doing some customization, going ahead and telling it the name of my application, so that way it automatically is populated throughout the help messages, going through and specifying versions, descriptions, right? Specifying what your prompt will look like, specify customized help task that's there, whoops. And then you just have to go through and specify your commands. So if you want to specify a command, really easy, you just write a function inside of Python. And with that function, you go ahead and specify whatever types of parameters I expect the user to be able to type after they type the command. And I then just output back whatever I want printed right into the screen itself. Notice the little decorator up there. If you're familiar with Python and never used decorators, all you do is you add this little decorator in front of the function, and that tells ctui that this function is actual command that should be exposed in the interface, right? If you don't have that little decorator in front of your function, then it's just a normal function and not going to appear inside of the application. Okay? The do in front of it is optional. You don't have to have do underscore. But what happens is the name of your function is what automatically appears inside of the tool as the command. The do is an optional component, but I always do it because then having the do in front of it, I'm never limited to keywords, right? Because sometimes a keyword may stop me from trying to use that keyword. So that's what the do's are for. The help menus for each of the commands are automatically built from whatever types of doc strings you specify for the function. So whatever you want it to appear in that little automatic drop-down list or in the help pages is just whatever's inside of the doc string, which you already should be writing for a Python function in the first place. Okay? And then, like I said, I'm just grabbing my output text, which I just grab it from the existing application, right? So what is currently there, go ahead and grab that. And then I just go ahead and add whatever I want to it. So I'm going to append this on, hey, directory contains, and then I'm going to go ahead and get a list of all the items from the directory that I'm currently in and print that back to the screen. Okay, so really easy to be able to write the command. Now, if you want something a little bit more advanced, right, and it does go a lot more, there's a lot greater features than just this, but to give you a little bit better idea for one step further, on this command, notice I have some type of an input that I'm expecting. So here I'm doing the cd command, and when you do a cd command in a command prompt, I have to specify which directory to change into. So I'm just naming that directory dir, right? And that's going to be how it's referred to everything down below it. And if you've never seen type annotation inside of Python, this is what it looks like, right? You don't have to do this inside of the tool, but there's an extra benefit if you do. If I say, hey, I want this to be a string, normally Python would just say, for type annotation, would just only use it for static checkers to make sure you don't have any problems. But I've added it to the tool that if I say, hey, this is a string or an integer or a floating point, it automatically will convert that for whatever it gets from the users inside the string interface. It'll automatically convert it back to the appropriate type for you. So you don't have to worry about trying to go through and do parsing of the information. It automatically parses all the arguments based on what you specify here. It'll automatically prompt each one of the users for whatever you specify there, right? And the way you specify the help messages for the parameters is just, once again, inside of the doc string. For the dir parameter, this is the doc string that's going to automatically be prompted inside of the interface itself. Okay, so it's automatically done for you. Then you just have to go ahead and call your dir change and then specify what you want to output to the screen. So if you've ever written Python scripts for probably less code than you're used to writing, you actually now have a graphical interface to be able to do the same thing. Okay, so that's what I'm so excited about this interface. So that is the Control Things project. You can go ahead and find that project, like I said, over at www.controlthings.io. This is an open source project, so I do have my personal email there. Feel free to reach out to me. I'm more than happy to answer questions, and I will be here at the conference as well, so you should be able to catch me between presentations if you have questions. I do have my cell phone just in case anybody needs it. I have my personal one for InGuardians. I probably failed to mention, but I am the director of ICS security for InGuardians, right, where we do penetration testing of control systems. And all my social media information up there as well for anybody that happens to need it.
All right, Justin has been an absolute leader in this community.